Okay, good. How do we do the first one? What's the best way of doing the first one? Square rooted. What do you need to remember if you square root it? Plus or minus, right? Two equations. 2x plus 1 equals 2, or 2x plus 1 equals negative 2. Solve them. 2x equals 1. No, x equals 1 half. 2x equals negative 3. X equals negative 3 halves. Right? Because we like that form when it's everything inside the square. Kill the square. Don't forget plus or minus. How about the next one? What's the best way of solving factor? So how do you factor that one? Right. Numbers that multiply to 12 add to 7. Set both factors to 0. That's it. Here all I'm asking you just to add the number. So what do you need to add to complete the square? 16. And we get 16 by taking 8, dividing it by 2, and squaring it. So this way you end up with x minus 4 squared, right? So that's it. What? That is it. Okay. So, new stuff. Let me give you two equations and see whether we can solve them. X cubed equals 8, and x to the 4th equals 16. We are okay with solving these types of equations when x is just squared, right? We just take the square root and we do plus or minus. And why do we do plus or minus, by the way? Why do we do plus or minus when we take the square root? What? Yeah, because the absolute value. You need to make, because the even exponents and all that. Well, how do you think you're going to solve the cubic? Take the cube root. Now, if you do the cube root, remember how the cube root or the power 3, they preserve the sign. The negative gives you negative, the positive gives you positive. Do you think we're going to need plus or minus here? No, because it's just x equals 2. Because only 2 cubed equals 8. Negative 2 cubed equals negative 8. So when you kill an odd power like that, you do not need a plus or minus. Is that okay? Well, how about the 4th power? Yeah, you will need a plus or minus there. So every time you kill an even power, you're going to need plus or minus. Okay? Because both 2 to the power 4 equals 16, and negative 2 to the power 4 still equals positive 16. So you do need plus or minus there. So in general, let's call them power equations. So when n is odd, then the equation x to the power n equals b is solved by taking the nth root. So if you have x cubed or something cubed, you take the cube root. Power 11, you take 11th root or whatever. You don't need plus or minus. That's the big thing. So if n is odd, you don't need plus or minus. But when n is even, you do need plus or minus. So the rest is the same as with extracting the square root. Okay, the only big thing here is just remember if it's an odd power, when you take that root, you don't need plus minus. So when the power is even, you're going to need plus minus. And again, one of the reasons because the way the absolute value works. Okay, so let me do a few examples. So I want to solve the following equations. Here is 1, x plus 1 to the power 5 equals 1. So this is very similar to what we just had on the quiz. On the quiz we had a square, here we have power 5. So we can get rid of the power 5 by taking the fifth root. Am I going to need plus or minus here? No, because of the odd power. So just take the fifth root of both sides. They'll give you x plus 1 equals fifth root of 1. And what is fifth root of 1? 1. So then the whole thing just comes down to x plus 1 equals 1. So then x equals 0. That's provided that all the variables are inside the power. Just like with the squares. If all the variables are inside the square, we can take the square root here. All the variables are inside the power of 5, so we can take the fifth root. If we had a lonely x floating elsewhere, we won't be able to do that. And we won't be able to do like the fifth. I mean, I don't even know what shape it is, right? The 5-dimensional.
Oh, we have 5 on the outside and 5 on the inside. Is that why it killed the
Yeah. Uh-huh.
What if it was 3 on the outside and 5 on the inside?
Well, then I wouldn't be doing that. If there was a 3 on the inside, then I would take the cube root. Because I just made up that fifth root. I put it there after I saw the equation. Because the equation just had power of 5. So I thought, okay, what kills power of 5? Fifth root. That's why I put the fifth root there. Fifth root was not the part of the original problem. I put it there to get rid of that power of 5. Let me show you another one. If I have 3 times x minus 4 to the power of 4 plus 5 equals 8. Right, so first would be to isolate that power term. Just like with the squares, we would have to subtract 5 and then divide by 3 to get the power term by itself. Okay, so before you start taking any roots, first isolate the power term. So 3x minus 4 to the power 4 equals 3. And then divide both sides by 3. You get x minus 4 to the power 4 equals 1. So just like with extracting the square roots, we would have to do that to isolate the power term. Well, now I have to get rid of the power 4. Okay? In order for me to get down all the way to x, I need to get rid of the power 4, and how do I do that? Fourth root, right? Well, am I going to need plus or minus here? Yes, because it's an even power, right? So take fourth root of both sides. Remember the plus or minus, x minus 4 equals plus or minus the fourth root of 1. And the fourth root of 1 is still 1, so it's x minus 4 equals plus or minus 1, which is two equations. X minus 4 equals 1, and x minus 4 equals negative 1. And then I can, they're pretty trivial. X equals 5, x equals 3. How's that? So that's not much different from what we've been doing earlier, just the higher power. So you use the higher radical. So just the one thing you need to remember, if you operate with an odd radical, you do not need plus or minus. When you operate with even radicals, you do need plus or minus. Questions on this? Good. Here's another one. X plus 1 cubed plus 27 equals 0. So what do you want to do first? Good, subtract 27. So subtract 27 from both sides to isolate the power term. Now what do you want to do? Cube root. Do you need plus or minus? No. Is that going to bother us that we're taking a cube root of a negative number on the other side? Is it going to bother us? Can you do odd roots of negative numbers? Yeah. The even roots, you cannot do even roots of negative numbers, but all you're looking for is a number such that if you cube it, it gets negative 27, so that's negative 3. Negative 3 cubed is negative 27. So that works. If this was a fourth root of even root, you would stop, say no real solutions. But the cube root of negative numbers is perfectly fine. It's just negative 3. Because negative 3 cubed is negative 27. Again, the odd powers and odd radicals, they preserve the sign. So negative give you negative. So then you would say no real solution. Then you cannot do. Even powers always come out positive, while odd powers, if the number is positive, then raising to the odd power give you positive, but if the number is negative, you end up with a negative. So that's that. Is that okay? Okay, well that's about all we need to know about these types of equations. We call them power equations. If you have, no matter what power is, you can always kill it. Again, provided that there are no extra variables floating around, that all variables are packed inside the parentheses. Okay? How's that? Does that feel good? It's not bad, right? Okay, well, let me do this now. Another type of equations that I want to discuss, equations that involve radicals. So kind of the opposite. Instead of having powers, I'm going to have radicals. Now here we have to be a little more careful. I'm just going to start you off with an example, and you won't have any problems solving this equation. You can almost do this equation by guessing. Here's an equation that involves a radical. Just take a guess. What do you think x is? 4. You're absolutely correct. Because the question is square root of what number equals 2? Well, the answer is 4, right? Well, how would we get to that more scientifically? How do you think, well, how would we actually solve this? We'll square both sides, right? So you want to, before when we had squares, we had to kill the square by taking the square root. Well, now we have a square root. So to kill the square root, you would, square. Because again, in this case, you can guess, but if that number was something other than pretty 2, you would have problems with it. But yeah, I can just go ahead and square both sides. Now, I don't need to worry about any of the plus or minus business, because square root of x squared is just x. There are no absolute values, not like that. The other side is 4. And we're done. That should make us happy. Right? Okay, now let me fix that. There is a problem sometimes There's a problem that occurs when you start squaring both sides of an equation. Now let me show you this example. Don't write this down, but I want to show you this example. I'm going to give you the simplest equation of them all, the easiest equation you see this whole semester. Here's an equation. What do you think the solution to that equation is? 1, right? There's nothing else but 1 solves this equation. Do you agree with that? Okay, now let me square both sides. If I, for whatever reason, I decide to square both sides, I'll end up with x squared equals 1, right? Well, what are the solutions to this equation? Plus or minus 1. All of a sudden, after squaring both sides of an equation, I'm getting an extra solution that does not work in the original problem, right? I just ended up with a -1. -1 does not equal 1. So sometimes when you square both sides of an equation, you create what we call an extraneous solution that does not work in the original problem. So you have to be careful. We're always going to have to check our solutions when we solve these types of problems, because a lot of times you're going to end up with what we call an extraneous solution. Okay? So that's really the only thing you have to pay attention to. The rest will be kind of similar. You're going to isolate the square root. You're going to square both sides. But then at the end, you're going to check your answers. Because sometimes you're going to have something square with extraneous solution. And if you had a cube root, you would cube both sides. Fourth root, you would raise both sides to the power 4 and so forth. Okay? Yeah? Well, you just say, well, that one works, that one doesn't work. That's it. You just have to identify it. Yeah. And I'll show you examples when we actually do that. But the steps, so steps to solve equations that involve radicals, the first step would be to isolate the radical. Isolate a radical. Sometimes you have more than one radical in your equation, so just isolate one of them. So when you get a radical expression by itself, well, kill that radical. And we kill the radical by raising both sides of an equation to an appropriate power. You have a square root, you would square both sides. You have a cube root, you cube both sides, and so forth. So raise both sides of the equation to the index of the radical. So again, cube root, cube it, fourth root, raise both sides to the power 4, and so forth. Okay? So this way you killed one of the radicals. You can have another one floating around, so you should still check for more radicals. If there are radicals left, repeat steps 1 and 2. So you're going to keep isolating and killing till all roots go away. So after you go through all that process, after you killed all the radicals, you're going to end up with some polynomial looking equation, no square roots. So just solve that equation, whatever you have left, solve the equation. And the fifth step would be to check your solutions, and you really have to do that. Because sometimes you get the extraneous solutions. So we're going to look for those, the ones that do not work in the original problem. And I'm going to do a few examples to show you how that works. Okay? All right. So here's an example, equation that involves a square root. Square root of 2x plus 3 equals 2. So the first step tells me to isolate the radical. Well, the radical is isolated. All I have is a square root on one side, nothing around it. So I can start killing that radical. Since that's the square root, I'm going to square both sides. Okay? So after I square both sides, I will end up with 2x plus 3 equals 4. Right? Are there any more radicals left in that equation? No, so I can go ahead and solve this equation, which is pretty straightforward. Subtract 3 from both sides, 2x equals 1. So divide by 2, x equals 1/2. Are we done? What's the last step? Check. You have to check, because there is a chance that this only solution that we got does not work in the original problem. Okay, so things like that happen when you start squaring both sides. So it's really crucial that we perform this check. So if x equals 1/2, I plug 1/2 back into the original problem. I have to make sure that that works. So it's 2 times 1/2 plus 3. Will that equal to positive 2? That's kind of how we check. Okay? So if I actually perform the computation, 2 times 1/2 is 1 plus 3. So that's a square root of 4. So that does equal 2. So that checks out. Okay. So that's our solution. So by plugging 1/2 back into the original problem, makes it balance. So we're done. Does that make sense? What we just did? Well, I'm just computing this, right? This part, I'm just putting 1/2 in for x. So 2 times 1/2 is 1, and 1 plus 3 is 4, so that's a square root of 4. Well, the square root of 4 is 2. Square root of 4 is not plus or minus 2. Square root of 4, remember how definition of a square root, it's always positive. Now here's another example. 3 times the square root of 1 minus x plus 5 equals 14. So the first step is asking us to isolate the radical. So it's not isolated, so I have to, subtract 5. So that's 3 times 1 minus square root of 1 minus x equals 9. And divide both sides by 3. So the square root of 1 minus x equals 3. Is that okay? So that's our first step, the isolation of the radical. The second step is killing that radical. How to go about doing that? So square both sides, so that will get rid of the radical. 1 minus x equals 9. Right? Are there any radicals left? No, so I can solve that equation. That's a very, So, right, but what does x equal to? Negative 8, right? You always want to get x by itself, but you're right. When you solve that, that's negative x equals 8. You still need to get rid of that negative. So it goes to the other side. Yeah, so just multiply both sides by -1. or divide both sides by -1, you should still get x equals -8. That's potentially a solution. When you're solving equations, it's always your variable equals some number. It's not, a version of your variable. But anyway, so we need to check that, plug back into the original problem. So x equals -8. If I plug it back into the original problem, so it's 3 times 1 minus -8 plus 5, will that equal to 14? And it looks like that's going to work, because negative and a negative give you a positive. So this is 3 square root of 1 plus 8 plus 5, which is the same as 3 times the square root of 9 plus 5, which is 3 times 3, which is 14. So that checks out. So that one works. Is that okay? So again, how you do this computation, it's up to you. You'll just have to make sure that by plugging the solution in for x, the equation balances out. All right. Let's try this example. 1 minus the square root of 2 minus x equals 2x. So what do you want to do first? Right, isolate the radical, so subtract 1 from both sides. Negative square root of 2 minus x equals 2x minus 1. Is that okay so far? Now, technically, we have to get rid of that negative in front of the square root. I mean, that will be following the directions. But if you think about this, I'm going to end up squaring both sides, so that negative is just going to disappear anyways. Right? Because to kill the square root, I'm going to square. So that negative is irrelevant at this point. Does that make sense? Even if if I go back to the previous problem, when I had that 3 in front of the square root, I can divide both sides by 3. I can just square both sides. The 3 will turn into 9, and the square will still go away. The bigger problem is the additions. The additions, that's what you need to get rid of. But if you have a constant multiple of the square root, squaring will still kill the square root. You just have a coefficient in front. Okay? So we can just go ahead and just square both sides. The negative will go away. It doesn't play that big of a role here. The left side just kills the square root. Negative turns into positive. So the left side is simply 2 minus x. There's nothing left. On the left, but what do we get on the right? Yeah, good. I'm glad you didn't just tell me it's something like 4x squared plus 1. Because we need to remember our formula. A squared minus 2ab plus b squared. Very good. So, are there any radicals left? No? So I can go ahead and solve this equation. That's a quadratic equation. So move everything to one side. Add x to both sides. Subtract 2 from both sides. So we'll end up with 4x squared minus 3x minus 1 equals 0. Looks like I should be able to factor that. I can just guess. Probably 4x minus 1 and then plus 1. Like that. Does that work? Yeah, you do get negative 3x in the middle. Again, remember, if it takes you more than 12 seconds to factor, you can just use quadratic formula on that. There are many ways to solve the quadratic equation. You don't have to factor every time. But factoring is just, it's a little easier if it's factorable, because then we'll set both factors to 0, solve the first one for x, so it's 4x equals negative 1, so x equals negative 1/4, and the other one is x equals 1, right? Are we done? Right, you have to check. You have to check both of them. You know, because again, both of them might not work at all. Both of them might work. One of them might work, the other one might not. So you really have to check both precisely. And we do that by plugging it back into the original. So check. So let's do x equals negative 1/4. So I'm going to plug negative 1/4 back into the original problem. Before we did any manipulations to that, back into 1 minus the square root of 2 minus negative 1/4, will that equal to 2 times negative 1/4? Right? Plug in negative 1/4 for every x in the original problem. And I just have to compute both sides separately, see whether they're equal to each other. So it's 1 minus square root of 2 plus 1/4. Will that equal to, what is 2 times negative 1/4? It's negative 1/2. Right? Well, 2 plus 1/4, it's 2 1/4, right? Or 9/4. 2 plus 1/4 is 9/4. Right? I mean, the easiest way to say it's 2 1/4, then you convert it. Because now I can take a square root of that very easily. What is the square root of 9/4? 3/2. So 1 minus 3/2 does in fact equal negative 1/2. So that balances out, so negative 1/4 works. Right? 1 minus 1.5 is negative 1/2. So that worked. So I'm going to go ahead and circle that one. That seems to be working. Right? And again, how you do your check, it's up to you. I mean, you don't have to follow those steps to a T. Just plug in, see whether both sides balance. But when I take x equals 1, and I plug it back into the original problem, right? You put 1 for every x, we end up with 1 minus the square root of 1. Will that equal 2? Right? Right side is 2, while the left side, what is 1 minus square root of 1? 0. So we have 0 does not equal 2. Right? So that doesn't work. So x equals 1, that's the extraneous solution. So the only solution is negative 1/4 to that equation. So this is what I was saying earlier. It's impossible to predict which one of this works without actually doing the very careful check. And that happens because we square both sides and we just created an extra solution. Fun? These problems are pretty lengthy, but if you just kind of dissect them into step by step, it's not that bad. You're killing that radical, you're solving whatever you have left, and then you're just checking both solutions. I mean, checking solutions is a good, habit to begin with. You just don't have to do it, but here you absolutely must because of those extraneous ones. Yeah? right, let's try this one. A square root of x plus a square root of x plus 2. Isn't that pretty? Equals 2. So all I see here is the 1 square root on the left equals 2. So the radical is isolated, right? All I see is a big square root. So I can go ahead and square both sides to get rid of that, the most outer square root. So all that squaring did is getting rid of 1 square root. So we're left with the radicand, which is x plus, happen to be another square root, equals 4. So we squared both sides, so that killed one big radical. So here's that step where I'm asking you, are there still radicals left? Yeah, so I'm going back and I'm repeating the process. I'm going to isolate and kill again. So here I need to subtract x from both sides to isolate the remaining square root. And then I'm going to square again to kill that radical. And again, I have to remember my squaring formulas. On the left, all the squaring does just kills the square root. So we're left with x plus 2. While on the right, it is 16 minus 8x plus x squared. How is that? Are there any radicals left? No, so I can go ahead and solve that, which appears to be a quadratic equation. So let's try to get 0 on one end. So this is x squared minus 9x plus 14 equals 0. Feels like I should be able to factor that. Numbers that multiply to positive 14 and add to negative 9. What are those two numbers? Negative 7 and negative 2. Very good. Product is positive 14, sum is negative 9. So then we'll go ahead and we'll set each one of those to 0. So x equals 7 and x equals 2. So there are times where both of these might work. There are times when none of them work. So we really have to check both very carefully. So I'm going to go ahead and plug in 7 into my original equation. I'm going to plug in 2 into my original equation. But are we okay how we got 7 and 2? So check. So x equals 7. So if I take 7 into the original equation, we end up with 7 plus the square root of 7 plus 2. Will that equal 2? Right, that's the original problem. So we can compute that from the inside out. 7 plus 2 is what? 9. So square root of 7 plus the square root of 9. Well, the square root of 9 is 3, so that's really square root of 7 plus 3, which is a square root of 10. That's not even close to equal to, right? So that didn't work. So x equals 7 is one of the extraneous solutions. It doesn't work in the original problem, so this is extraneous. Doesn't mean that x equals 2 works. So I have to check. I really have to check both of them very carefully. So if I take 2 back into the original problem, 2 plus the square root of 2 plus 2, will that equal 2? And that seems to be working. Because if I follow the order of operation, this is square root of 2 plus the square root of 4. And the square root of 4 is 2, so this is square root of 2 plus 2, which is the square root of 4, which does equal 2. So that checks out. So the only solution that we have is x equals 2. So solution here is x equals 2. Okay, all that work gave us one little solution. How's that? All right, good.